Hello guys, welcome to our YouTube channel. Welcome to Add Maths Plus Maths. I am now going to discuss another lesson in additional mathematics, which is part of our chapter 1 about functions, which is composite functions. When we say composite function, a composite function is formed from two or more other functions. So instead of doing two steps, use the composite function and do it all in one go. Example, I have here f of x is equal to x squared and g of x is equal to 2x. If the value of the x is 5 inside the f of x, the value of f of 5 will become 25. And if I will have that 25 as an input to the g, then the value of the g of 25 is equal to 50. Now, how if I am going directly from 5 to 50? This is what you call composite function. And the value of from 5 to 50 is what you call g of f of x, which is equivalent to 2x squared. Why is it 2x squared? Because the f of x becomes an input to the g. I repeat, the f of x becomes the input of the g. The domain of the f and the domain of the g of f are the same. The domain of the g and the range of f are the same. The range of g and the range of g of f are also the same. Okay? So these are the ideas that you are going to use when we are talking about composite function. Next, g of f of x means put f into g. I've said that a while ago already. So do function f first. This is very important. Why? Because g of f of x is not the same as f of g of x. So if you are asking yourself, is g of x the same as f of g of x? No, it's not the same, or they are not the same. Let's try to explain this one. If I am going to switch f of x and g of x, let's bring back the value of x on the first function as 5. If the value of the x on the first function is 5, then the value of the output will become 10. Remember, our first function this time is g of x. So 2 times 5 is equal to 10. If the second function is f of x, and our input is the output of the g, then 10 to the power of 2 is equivalent to 100, which is not the same as our output a while ago. And f of g of x is considered to be the quantity of 2x raised to the power of 2. While, if you compare it with the g of f of x a while ago, it is 2x squared value. Now, f of g of x means put g into f. G of f of x a while ago means put f into g. Now, put g into f. So do function g first. So f of g is not equal as g of f. Is it possible to have f of x? Yes. Let's take a look at this example. I have f of x is equal to x squared. And on the second function, I also have f of x is equal to x squared. Let's try to put in the same input, which is 5. If the input is 5, the output of the first function, which is f of x, is equal to 25. That output, 25, will become the input into the second function, which is also the same as f of x. And if you have 25 as the input, the output will become 625 because 25 squared is 625. Now, if you come from those two functions, that is what you call composite function. And that is f of x, which is x to the power of 4. Why is it x to the power of 4? Because x squared to the power of 2 is x to the power of 4. F of x means put f into f. This is also written as f squared of x, because basically f times f is equal to f squared. But it doesn't necessarily mean you multiply the two functions. Okay? Let's do some examples. The function f is defined by f of x is equal to x minus 2 squared minus 3 for x is greater than negative 2. The function g is defined by g of x is equal to 2x plus 6 over x minus 2 for x is greater than 2. Find f of g of 7. As I've told you a while ago, we have to work on the second letter first. It's written as f of g. So you work on to the g first rather than working on to the f first. So do function g first. If I want to do function g first, I'm going to change the value of the x on the g with 7 because it is said f of g of 7. So work on that, you will get 4. That value of the g of 7, which is 4, will be the input into the f, which will give you 4 minus 2 squared minus 3, which will give you an answer of 1. This will give you a conclusion that f of g of 7 is equal to 1. Now let's move on to the next work example. F of x is equal to x minus 1 for x is an element of all real numbers, and g of x is equal to x squared plus 5 for x is also an element of all real numbers. Find letter A, f of g of x, letter B, g of f of x, and letter C, f raised to the power of 2 of x. For letter A, you notice that it's written as f of g of x, meaning g of x will be an input into the f. I repeat, g of x is an input to the f. Thus, it will give you an idea that you have to put g into f first. If you have to put g into f, then it will be 2g minus 1. And remember, the value of the g is x squared plus 5. This x squared plus 5 will be multiplied to 2. So it will become 2 times x squared is 2x squared. 2 times 5 is 10. That 10 will be minus by 1 or subtracted by 1. Then it will give you an answer of 2x squared plus 9. Letter B. It says g of f of x, meaning put f into g. If I will put f into g, then that x value in the g of x will become f, which is 2x minus 1, or it will become f squared plus 5. Okay, and if I will change that f to 2x minus 1, it will become 2x minus 1 squared plus 5. This 2x minus 1 is a square of a binomial. You just apply your square of a binomial, it will become 4x squared minus 4x plus 1. Then you add that excess plus 5. 1 plus 5 will give you 6. So your answer here is 4x squared minus 4x plus 6. Let's move to letter C. F squared of x, meaning f of x. Therefore, put f into f. If I will put f into f, it will become 2f minus 1. And the value of that f is 2x minus 1. Since the value of the f is 2x minus 1, I'll just distribute that 2. 2 times 2x is 4x. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. Therefore, it will become 4x minus 3. So these are the answers for the work examples. Let's now move on to some questions or past year questions about this lesson. First example. The function f is defined by 2 plus square root of x minus 3 for x is greater than or equal to 3. The function g is defined by 12 over x plus 2 for x is greater than 0. We are asked to find g of f of 12. It will give you 2 marks in your paper. So if you are looking for g of f of 12, you have to study that f of 12 is written at the end, meaning you find first the value of f of 12, and whatever is the value of the f of 12 will be the input into the g. Okay, let's try to do. G of f of 12 is equal to 2 plus square root of 12 minus 3. What happened? Remember, f of x is 2 plus square root of x minus 3. This x becomes 12 since we are changing the value of the x into the f by 12. So it will become 12 minus 3, and 12 minus 3 is equal to 9, so therefore it will become g of 2 plus the square root of 9, and square root of 9 is equal to 3. Therefore it will become g of 2 plus 3, and 2 plus 3 is equal to 5. So we are now going to evaluate g of 5, meaning we change the value of x and will become 5 on the g. This will become 5. The value of the x here will become 5. It will become 12 over 5 plus 2. And 12 over 5 plus 2 is equivalent to 12 over 5 plus 10 over 5. I changed the 2 to make the denominator the same. And 12 plus 10 is 22. Copy the common denominator, which is 5. It will become 22 over 5. And if you change it to mixed fraction or mixed number, it will become 4 and 2 over 5. There. Second example. The function is defined by f of x is equal to 2x plus 1 squared minus 3 for x is greater than or equal to negative 1/2. The function g is defined by g of x is equal to 3 all over 1 plus x for x is greater than negative 1. Find the value of x for which f of g of x is equal to 13. The value of the composite function is already given, which is 13. What you need to do is to find out first what is f of g of x. You notice that g of x is written last, okay? Or f was written first, then g of x. So it means g of x will be an input to f. So what is the g of x? 3 over 1 plus x. Thus, it will give you an idea that will be f of 3 over 1 plus x is equal to 13. And remember, f is 2x plus 1 squared minus 3. This x will be changed to 3 over 1 plus x. I repeat, this x will be changed to 3 over 1 plus x. If you will change that, it will become this format. Okay? The 2 is still there, 2. Then the x becomes 3 over 1 plus x, then plus 1, then you square, then minus 3. If you want to solve for the value of the x, okay, and you want to find out the value of the x, you have to do algebraic rules. I want to remove first this negative 3. If I want to remove first that negative 3, I'll add both sides by 3, which I'll give you 16. 13 plus 3 is 16. So I was able to remove that negative 3 on the left side, or minus 3 on the left side. Next, I want to remove the square. If I want to remove the square, I'll square root both sides. It might give me two possible answers. On the right side, it might give me positive and negative value. But remember, your restrictions are almost all are positive. Okay? So I won't care if I'll have a negative value. Okay? Next, I'll move to that one. So it will just be a positive value. Next, I want to remove this positive 1 over here and move it, or plus 1 over here and move it to the right side. Or remove that by subtracting both sides or taking away 1 from both sides. It will give me an answer that it will become 2 times the quantity of 3 over 1 plus x is equal to 3. Then I need to remove that 2. Okay? Basically, it's being multiplied, so what I need to do is to divide both sides by 2, which will give me 3 over 1 plus x is equal to 3 over 2. Remember, you will have two equal numerators, so I can already equate the denominators. X plus 1 is equal to 2. Why suddenly it becomes x plus 1? It's the same thing as 1 plus x. Okay? And if you want to make x the subject of the formula and you want to find the value of x, you subtract or take away that 1 from both sides. If we take away that 1 from both sides, then x is equal to 1. Thus, the value of the x is 1. Let's move to the next example. The function f is defined by f of x is equal to x plus 1 squared plus 2, or x is greater than or equal to negative 1. Remember, I said a while ago, if you see f squared in our functions, it means f of f. Thus, f squared of 1 meaning f of 1. Okay? Thus, will give you an idea that I am going to look first for f of 1, and whatever is the value of f of 1 will be the input to the f again, once again. Thus, it will give me f of 1 plus 1 squared plus 2. And 1 plus 1 is 2, will give you an answer that it will be f of 2 squared plus 2. 2 squared is 4, so it will give you 4 plus 2, and then f of 6. Thus, I am going to evaluate f of 6. Okay, meaning 6 will be our input into the f. Finally, we'll give you 6 plus 1 squared. And 6 plus 1 is 7. 7 squared is 49. 49 plus 2 will give you 51. Okay, so the value of f squared of 1 is equal to 51. Now let's move on to the next example. The functions g, h, and k are defined for x as an element of all real numbers by g of x is equal to 1 over x plus 5, where x is not equal to negative 5. H of x is equal to x squared minus 1. K of x is equal to 2x plus 1. Express the following in terms of g, h, and or k. Number 1. 1 over the quantity of x squared minus 1 plus 5. You will notice that from the functions that we have, it is only g of x that is in fractional form. If it is the only one in fractional form, then definitely it is involved in our answer. And you will notice that in g of x, x was changed to be x squared minus 1. And will give you an idea that h of x became an input into the g. Thus, your answer will become g of h of x. Okay, next, let's move to number 2. It is 2 over x plus 5 plus 1. Again, there is a fraction part, and you will notice there's a plus 1 there. This plus 1 will give you a clue that k of x is included because it is the only thing that has a plus 1 at the end. And then the 2 is still there. You will notice there's a 2 here. What do I multiply to 2 so that it will become 2 over x plus 5? I multiplied that g of x value, which will give me an idea that g of x served as an input into the x of the k. Thus, it will give me the answer that it is k of g of x, because g of x became the input into the k. Next, last example. Functions f and g are defined for x as an element of all real numbers by f of x is equal to 3 minus x and g of x is equal to x over x plus 2, where x is not equal to 2. Find f of g of x. Okay, so if we want to look for f of g of x, g of x will be an input into the f. Therefore, I'm just going to change the x on the f and will make it the value of the g of x, which is x over x plus 2. There, it will become 3 minus x over x plus 2. Question number 2. Hence, find the value of x for which f of g of x is equal to 10. We know already that f of g of x is 3 minus x over x plus 2. Therefore, for question number 2, it will become 3 minus x over x plus 2 is equal to 10. This comes from our answer in question number 1. Okay, then you will just basically take away that 3 from both sides. It will become negative x over x plus 2 is equal to 7. And then multiply both sides with the negative number so that I can remove this negative number. It will become x over x plus 2 is equal to negative 7. Then, to remove that denominator, I will multiply both sides by x plus 2. It will become x equals negative 7 times the quantity of x plus 2. Now, it will give me an idea that it will be x is equal to negative 7x minus 14, because negative 7 times x is equal to negative 7x. Negative 7 times 2 is negative 14. If I want to make the subject of the formula the x, Then it will become x plus 7x is equal to negative 14. And x plus 7x is equal to 8x. So 8x is equal to negative 14. You divide both sides by positive 8, it will become negative 14 over 8. And if you want to simplify, it will become negative 7 over 4. Or if you want to change it into a mixed number, it will become negative 1 and 3 over 4. This will be your answer. Thank you for listening and thank you for watching this video. Please don't forget to like and share. Subscribe for those who haven't subscribed yet, and click the bell button. Click it all so that you are notified with our new videos in mathematics and additional mathematics. Thank you.